Okay, so the next section is section 2.5, the modern view of atomic structure. So now we know that the atom contains electrons, protons, and neutrons. So electrons are found outside the nucleus and they're negatively charged. So the mass of an electron is 9.109 times 10 to the negative 31st kilograms, and its charge is -1. Protons are found inside the nucleus. They're positively charged, and the positive charge, is equal in magnitude to the electron's negative charge. So their charge is +1, and the mass of a proton is 1.673 times 10 to the negative 27 kilograms. And I'm just giving you these mass numbers. You don't need to memorize them, but you do need to know that the charge of an electron is -1 and the charge of a proton is +1. So neutrons are also found in the nucleus, but they have no charge and they have virtually the same mass as a proton. So the mass of a neutron is 1.75 times 10 to the negative 27th kilograms, and its charge is 0. There's no charge. So the nucleus is small compared to the overall size of the atom, and it's extremely dense. It accounts for almost all of the atom's mass. So this is what a cross-section of an atom would look like. So this is obviously not drawn to scale, but the thing to notice is that the nucleus is tiny compared to the overall size of the atom. Okay, so the next definition that we need to talk about is isotopes. So isotopes are atoms with the same number of protons, so that's important, same number of protons, but they have a different number of neutrons. So they show almost identical chemical properties to each other, because chemistry of the atom is due to the electrons. So in nature, most elements contain mixtures of isotopes. So the next slide is going to show you 2 isotopes. So these are isotopes of sodium. So if you look here, these symbols show you the atomic number. So let me write this down here. So if this is sodium, then the numbers that are contained here. So I'm going to copy it for sodium 23. So this is the atomic number, and this is the atomic mass. And then Na is the element symbol for sodium. So what you can see here is that this sodium has 23, or has an atomic mass of 23, while this sodium has an atomic mass of 24. So the difference between these two are the neutrons. So the one on the left has 12 neutrons, and the one on the right has 13 neutrons. And the way that we can calculate how many neutrons it has is by looking at the atomic mass. So for this one on the left, the atomic mass is 23. So I'm going to abbreviate that AM. And the number of protons is 11. So 23 minus 11 equals 12. So that's how many neutrons it has. On the right, same thing. 24 is the atomic mass minus the number of protons gives us 13, and that's how many neutrons we have. Number of protons always equals number of electrons. Okay. So the isotopes are identified by the atomic number, which is what I just talked about on the other page, which is equal to the number of protons. So that's where that math comes in. The mass number is the number of protons plus the number of neutrons. Okay? So it's always written like this: mass number, atomic number, and then the symbol for the element. So we get the atomic number and the mass number from the periodic table. So here I've circled sodium. So the mass or the atomic number is 11 and the mass number was 23. So they just rounded that number up since it's 22.99. A certain isotope X contains 23 protons and 28 neutrons. What is the mass number of this isotope? So remember, mass number is equal to number of protons plus the number of neutrons. So 23 plus 28, you get 51. So this is the mass number. Okay, so now we can use our mass number in order to figure out what our element is. So let's go back to our periodic table and we will look at our masses. So the closest mass number to 51 is 50.942 and the element is vanadium. Okay, so the mass number was 51 and the element is vanadium.